Hello, is it audible?
Yes, sir.
Yes, sir.
Can you see the screen?
Yes, sir.
Yeah. Okay, so today we will discuss about how Arduino board provides a facility to interact with analog sensors. It also how it interacts with analog devices. As I said in the beginning session, a microcontroller should have the capability to talk to the devices, which is of two types in the world. One is a digital devices, other is a analog devices. We have seen in the last session how to talk to the digital devices using a digital read and a digital write functions so that I can able to interact with the digital input devices and also digital output devices. In this class, we will learn about completely about the analog concept of about a microcontroller, the way it works, how the signal has to be handled, how the signal has to be measured, what is the resolution, study them. So as we already studied about the Arduino architecture, if you look at the Arduino architecture, it provides a facility to talk to the analog devices through the analog inputs. There are about 6 analog inputs are there. And there are certain digital pins with a tilt symbol around 6 such pins are there, which can be considered or which can be simulated or which can be used for analog outputs. So if somebody asks how many analog input devices, how many analog output devices you can connect with Arduino board, I can tell you 6 analog input devices I can connect, 6 analog output devices I can connect it. Now we will start understanding how does it works, analog concept will work. Now any analog concept, basically the concept of analog signals works with the following principle. Let's consider a waveform. I am plotting the waveform with reference to time. Another axis can be, now I'm taking a voltage. To start with, I'll take a voltage. Now, if let's say this is the range of the voltage is 0 to 5 volts is my range of voltage. Now my signal varies here. My signal varies like this. The maximum is 5 volts. The minimum is 0 voltage. In this, it ranges here. Now, if somebody asks what is a voltage, that means that it is between the 0 to 5 voltage and specify certain voltage. It can be 1.1 voltage. It can be, let's say, it can be 0.5 volts. If I say at this time, what is the voltage? I can just specify 2.8 voltage. If this point of time, I can specify 4.8 voltage. Like this, I can able to specify. That means that many of the sensors available in the industry, which are available to measure the physical quantities around the world. What are the physical quantities? Temperature, the humidity, light. These are all the physical quantities. They vary with time. So when you want to measure them using a computer, you have to bring their data into what is called as electrical domain. That means that you have to convert them into proper voltages and currents. After you convert them into voltage and current, you can get this type of waveform, what you are seeing on the screen. So these waveforms nothing but represents the output of the sensors, which in turn represents a certain physical quantity. Now, so these values, whatever the values I have, unless I bring them to the digital domain, I cannot do the computation. So what are the digital domains? It is basically what 0, 0, 1, 1, 0, 0, like that. That is, I have to bring them into digital domain. Now, when you want to bring them into the digital domain, the question is asked, how many bits of digital data you want to produce for every input of data you want to measure. For example, at this juncture of time, I have certain voltage now available, which is generated by the sensor. I want to convert them into digital. Now you should take a decision. How many bits of digital data you want to represent, how many bits of digital data you're going to use, how many bits you're going to use in the digital output to represent this physical quantity. So the more the bits, it is always better. Because why? You can able to represent even a smallest change possible within this range. So this is the range, but this range can be represented infinitely by small values. For example, I can represent as what? Minimum is 0.1.2, or I can go little more subtler values, 0.01, 0.001, 002. That means that the more the number of bits you have, the more accuracy you can able to get, and more accurately you can able to represent your physical quantity or the voltage quantity generated by the sensor in a digital domain. But the problem is the microcontrollers should have the facility to convert this voltage or analog values into this digital domain. So whenever you want to convert this analog values into digital domain, the question is how many bits you're going to use. The more the bits used, it's good. Cost of implementation will be more. So the hardware which is used inside the microcontroller or the chips are available outside the microcontroller, those chips are called as ADC chips, analog to digital converter. They're called as analog to digital converter. So these can be inside the microcontroller, inside MUSI, or you can use external one also. I can able to use it. Now, so if the number of bits what the ADC generates is more, the cost of the ADC is more. In the sense, implementation cost will be more. So generally, most of the microcontrollers provide 10-bit ADC. So if I use a word called 10-bit ADC, so 10-bit ADC, so that means Arduino provides inside a 10-bit ADC. What does it mean that? That means that it accepts analog input. It accepts analog input. So whenever you are giving analog input, it's always with reference to what? With reference to what? Ground pin. That means that you are applying a voltage 0 to 5 volts here. You are applying the voltage here. That is always with reference to what? Ground. So you are producing 10-bit digital output. So if I consider this is D0 and this is D9 like this, so this is totally 10-bit. So this is called as a 10-bit ADC. Now, so whenever you have a 10-bit ADC, you should be able to know that how do you represent the voltages, analog voltages, and the corresponding digital outputs. For example, what is the minimum voltage? 0 voltage. What is the maximum voltage I can have? Is a 5 volts a maximum voltage. So corresponding to that, 0 means what? All the bits are represented by 0. When corresponding to 5, all the bits becomes what? 1, 1, 1, 1, it becomes. Now, If you're going to change this by 1 bit, then in the sense you want to just make a change in 1 bit, that is 0 becomes 1. Now what is the voltage you have to apply here so that I can produce a 1 bit change? So that we call as a resolution. We can call as a resolution. So that is equivalent to, for example, for 5 volts, for totally, let's say it's 1024, 10 bits are there. So 1024, so 5 volts divided by 1024. Now, so this gives the resolution. So approximately, whatever it may be around 10 millivolts or whatever the value. So that will be the resolution, we call as a resolution. So 5 volts divided by 1024. For 1024, you're going to get what? Because this is what? 0. This is 1, 2, 3. It continues like this. The value becomes what? 1023. Because how do you got the 1024? 2 to the power of 10. So 2 to the power of 10 is what? 1024. So that means that, so the maximum value you can represent using the 10 bits is how much? 1024. So the values range from what? 0 to 1023. So that means that for 1024, you're going to get what? The 5 volts. For what is the voltage you're going to get for 1 bit? So this is the formula. So this formula gives me the resolution. What is the resolution of an ADC? Resolution of ADC speaks about what is the minimum voltage you have to apply here to make a 1 bit change at the output. That is called as a resolution. So if I increase the denominator of this formula, that is instead of 1024, if it's a more, when it is a more, number of bits 10, instead of 10, it becomes a 12. It becomes what? 2 to the power of 12. So in such cases, what will happen? The resolution also becomes reduces. That means that you can able to measure even finer values of voltages. So if somebody uses a mobile, he has got an ADC inside to record your voice, to recognize your voice. More the bits is ADC they have used, it means that it is enabled to recognize even a small variations in your voice. That is why it's always, any equipment, if you take it, if the number of bits in ADC is more, it's always a better, because you can able to identify even a small changes in the inputs from the sensor. So many times in the project, you find out, you get a sensor which produces a small changes in micro voltage. Micro voltage you cannot measure in the Arduino ADC, because Arduino ADC is what? Minimum of around 10 millivolts. So that means that your variations are less than 10 millivolts, but you want to recognize it. Then what you have to go for? Purchase an external ADC chips, which is available as a shield to the Arduino board. That, let's say you go for a 16-bit ADC. Then what will happen? 5 volts divided by 2 to the power of 16. Even a small micro voltage changes you can able to measure. So when you do a project, keep it in mind that if the variations in your sensor output is less than the resolution, what you have to do? Either go for higher bit resolutions size ADCs, or you have to use an amplifier and amplify the sensor output voltage changes so that you can able to recognize those changes in the ADC of the Arduino board. So now I have understood the fundamentals about, so what is required for understanding the analog pins. Now we'll go to the next concept. Now, so once I know that it's a 10-bit ADC, there are now 6 outputs are available, 6 inputs available from the Arduino. I can measure 6 analog sensors using that one. Now we will go to the circuit design. We will start using those analog inputs, and we will learn how to use them, and some more fundamentals we will learn from that. So now what I will do, is it visible? Tinkercad is visible? Hello?
Yes, sir.
Yes,
It's
sir,
visible.
yes, sir.
So now I've just taken an Arduino board. Now I'll just take one breadboard. I have taken a breadboard. So I will reduce the size of the board in this one. Okay. Okay. So now what I will do is, I will start building certain minimal components which is essential to understand the analog inputs. Now I will, as usual, whatever required, we will just prepare the bus. So I will connect the bus and keep it ready for doing the okay. Always whenever we want to learn about analog, you have to simulate a sensor. Get a component in a market. Through that, you can simulate any sensors, any analog sensors. So which is that component? If somebody asks, I don't have a sensor, but I want to build a project. I want to simulate the whole project by making the inputs, creating myself using some other component. That means that a component which simulates any sensor, analog sensor. What is the property of analog sensor? Analog sensor, it can produce any voltage between 0 to 5 volts. That is a property of any analog sensor. Now I want to simulate that voltage 0 to 5 volts. So if I take a resistor, it's a fixed. I can divide the resistors, I can get a fixed voltage, but I want a variation of a resistance. That is variation of a resistance. That means through variation of resistance, I can produce a variation of a voltage. As you already studied in the basics of electronics, that is what is called as a potentiometer. So I can use potentiometer to perform those changes. So let's select a potentiometer and bring it here. So a potentiometer, I can select the range. For example, if I say 10 kilo ohms, that means that, so I can make this potentiometer, I can vary this, there's a knob is provided. By varying the knob, I can produce a value, anything between the 0 to 10 kilo ohms. Any potentiometer will have 3 leads will be there, 3 leads. Terminal 1, so wiper, and the terminal 2. Terminal 1 and 2 should be connected to the fixed voltages. Terminal 1 should be connected to the, let's say, 5 volts. Terminal 2 should be connected to the ground, and third point will be the variable resistance point. So let's look at here for a moment. So I'm just producing that output. Okay. Now, so a potentiometer will be like this. So it will be like this. So one point I am connecting to the 5 volts or 3.3 volt, that depends upon the sensor we want to simulate. The other point I'm connecting to the ground, and this is the point where available. So this point, and with reference to what? Ground, with reference to ground, so gives me any voltage, correct? Now, say it's nothing but, so 0 to 5 volts, you can simulate for between these 2 points. So I have taken now, so such component so that I can simulate the sensors. So now these 2 points I should be able to connect to the fixed 2 voltages. So now what I will do is I just bring it here. I have connected to the one to the ground. So I have connected other point to the VCC. Now I connected. Now I left out with the center point. Center point is nothing but a variable voltage it produces. So that I have to connect it to where I said whenever you take any analog input devices, I will just connect to this one. I have connected here. So now I have connected a potentiometer to the Arduino board. This is the way connections I have to do it. Now I'll start doing the code for this. Now, since I'm using now analog, I want to measure the analog. So what I'll do, let's say I said that whatever the value you generate here, that is 0 to 5 volts, internally it is converted by the ADC present in the Arduino microcontroller. That means that, so as I've already shown in the diagram for you, 0 to 5 volts input will correspondingly convert into what? 0 to 1023. Because why? it has to be digitally converted before computation. Now I want to see that if I change this one 0 to 5 volts, do I get 0 to 1023 in the input of the Arduino microcontroller? So for that, what I'll do, I'll declare an integer x, that this is a digital output for me. So digital output. There are two functions are provided similar to the digital functions which are used to handle the digital input outputs. So two functions related to the analog is called as analog read and analog write. So we will use analog read first. Analog read. Now, what is the input? Here there is, since it's already input, there is no question of pin mode setting is not required. Here, why? Each pin is capable for reading and writing, so that I have to set the pin mode. Here it's already input, so there's no meaning of setting is required, not required. Even if you said people set it in progress, but it's not required. So I'll say A0. So I'll specify it. You can give a name also. Instead of A0, you can constant integer. So some name you can give it. Potentiometer equals A0, like that also. You can type it and you can give a name for this one. So I've used analog read A0. Now, if I take this value X and observe the value of the X, I can see that there is a digital output correspond to this one. So what I'll do is two things I'll do it. Now, to see that whether this is varying or not, whether my circuit is proper or not, then I want to observe that whether X is properly varying or not. So for what I'll do is, to start with, so I will put on a multimeter here so that I will observe whether when I change this one, voltage changes or not. So whatever the component I'm going to use, you have to experiment the same thing with actual components. Then only you learn the subject. So now I will use a multimeter. So there is a multimeter is available here. So you can just check where is the multimeter. Okay. So I'll use a multimeter. Now multimeter, you can set for whatever the measurement. Now I want to measure the voltage. That's why I have left that like that. I'm not changing this one voltage. Now multimeter will have 2 points. One plug, I'll bring it here. I'll put it to A0. That is, I want to monitor what are the voltage changes happens here. Whether it's changing or not, my circuit is proper or not. Whenever you purchase the sensor-based project, this is a major challenge. You connect a sensor, your program is not working. You think that, so a program problem is there. Actually, it will not be a program problem many times. Your voltage itself is not being generated by your sensor circuit properly. That is why before running your program, use a multimeter and check whether the voltage is changing happening here or not. The same way you have to do it, whatever the way I'm telling you. So now take the negative, connect to the ground point. So connect to the ground point. So what are the things you have to do? Multimeter, whatever you have with you, the real multimeter, change the knobs such that voltage setting should be there. Number one. Then what will happen? The 2 pins, whatever you want to measure, you connect there. So I want to measure the voltage change here. So I have connected it here. Now what will happen? So I will run the program. I am not interested in the, even though I'm not outputting, I'm not outputting the X to anywhere to measure it, but I'm interested to only measure the changes through multimeter. So I just run it as it is. So I'm not concerned about the program to start with. I want to just measure. Now, what is a potentiometer? They provide a knob. Potentiometer will have a small knob will be there. You can rotate that knob. You either screwdriver or through your the fingers or finger or nail or whatever it may be. Depends upon the potentiometer. See that as a vary, it is varying. How much it varies? So because I'm using setting the potentiometer for what? 0 to 5 volts, I'll get a maximum 5 volts. See exactly 5 volts I can change. So that means that my hardware circuit is proper. So that means that the sensor is producing proper voltage at the required pin. Hardware is correct. Now you have to tackle this one. What is the way to tackle? Since the signal is coming here, write a proper program, put that program in the Arduino microcontroller, convert that into digital value, whatever it is already done inside, then put it somewhere. Now where do you put it? When you build a small...
I have a doubt regarding...
Can you ask the doubt at the end so that recording will be easy?
Okay.
Okay. So now I want to measure, I want to display this value X. So then only I can see. But whereas if we take a look at this problem, this project, where is a monitor? There is no monitor is there. There is no computer monitor is there. So since microcontroller projects do not have an output device like a monitor, it is very challenging to display certain values on the screen. For example, in a normal C, printf means it will come to the screen. Here, where should it go? Because there is no monitor is connected here. So in such case, for that, they have provided what is called as, that is why TXT RXT is provided. See, look at these 2 pins, TXT RXT. So these 2 pins and also the USB cable is there. No, here also TXT RX is there, inbuilt, one more port. That means that microcontrollers have the ports which can throw the data in a serial fashion using TX and RX pins, either this or this. So when they throw the data through a serial fashion, so the external computer can catch the data and provide a software to display that serial data into a parallel format. Those types of softwares are called as serial monitor softwares. So Putty is one such, FlashMagic one such, even Arduino has got a serial monitor. So there are a lot of softwares are there. What are the names of software? You can call it serial monitoring software. What is the job of these softwares? These softwares will receive the signal on TX-RX generated by the microcontrollers, convert them into USB format, and then catch them and show you on the screen in the computer. So same way we are doing here also. So you require a serial monitor software that is provided by the Arduino itself. If you use other microcontrollers, they do not provide, then you can use FlashMagic, Putty, like softwares available, which you can use to display the data coming on the serial ports. That is a TX-RX lines of those modules. Now, I have to throw the data into the Arduino serial monitor. For that, what are the settings required? So first of all, you should enable the serial communication. To enable the serial communication, what is the meaning of enabling a serial communication? That means that, so I said there is a software is available on the computer side which catches this data and displays it. And here is a microcontroller which has got a pins TX-RX which throws the data. But the rate at which you throw the data, the rate at which the software catches it should be the same. So if you're throwing at a slower speed, you're catching at a faster speed, you're expecting it's coming at a faster speed, then data will be not proper. You will get a different data. If you send A, you may get a star. So that is why you should know what is the speed at which it should be able to throw the data. So now I have to configure. That means that configure the serial port of the microcontroller to a particular speed. Make sure that the serial monitor, whatever you use, the software, there also configure the speed to the same thing. So to configure that, they have provided a function serial dot begin. So serial dot begin 9600. So just check that whether that statement is correct or not. So if any error is there, you can change it. So okay. So I think statement is correct. Begin statement is correct. Then what should I do it? Now I will able to throw this data now. So serial function has also provided another function serial dot print function is also there. Using print you can store, you can throw either the string or the value integers or a float variable, anything you can throw. So one more function called println. The difference between println and print is, so in the println, one new line is created. That is, it print the value. It's like a /n in the C language. So I'm just throwing the data called x there, equals, that's all. So this is my function. So this is a method, you can use it to debug your programs. So whenever you build hardware projects, what you have to do is, you should always to use these two concepts. That means that in between the program, keep throwing some data to the serial monitor and check whether your logic is working or not. If something is available for debugging in Arduino boards, this is the only thing available for debugging it. In the Arduino boards, actual Arduino Studio, you cannot stop the program step by step and debug the programs. It is not possible because it's in the hardware. So you to run the whole code at a shot on the board. You cannot stop it step by step. For that, you require a different type of debuggers are required. It is costly. So with the board, you cannot do that one. So what is the best way to do debug your projects? Throw the data to the serial monitor in between the logics. See that whether your previous logics are working properly. So now I've just written this code. So now what I'll do, I'll run this program now. So if I run this program, so where is the serial monitor? So you can just see that here is a serial monitor is available. So I will just pull this. I will stop for a moment. I will just push this little here. So start the simulation. So then I use a serial monitor. Now look at the serial monitor is throwing the values. See, it's throwing the values, different values here. So what I said, these values should be corresponding to what? These values should be corresponding to the voltage you are setting here. Yes or no? One moment. I'll just change the position of the multimeter also. I'll change keep the position of the multimeter here. Now start the simulation. Okay, now I'll say code. Now you can see that multimeter is there. This is the actual voltage you're applying. and this is the actual digital value which is present inside this microcontroller. Now I'll change the potentiometer. I'll change the potentiometer. See that as I change, the voltage is changing here. When I change the voltage, digital value is changing. What is the range of this digital output? 0 to 1023. What is the range of input voltage? 0 to 5 volts. That means that you are converting analog into digital. See that as I change, it is changing. See, as I change, so I can 4.48, 4.8. See, it's becoming a 1023 when it reaches 5 volts. So again, when I reduce, see the values. Keep observing the values here. See the values is changing every time. When you change the voltage, the serial mount output is also changing. So what does it mean? That means that it is possible to convert analog values of 0 to 5 volts, quantize them, convert into digital value, and put it in the microcontroller. That you can use it for a number of applications. So this gives an idea about how analog pins is going to work. Now we'll continue with the program. Now we'll understand some more concepts. Okay, now I want to now convert this value into the voltage and also print the voltage. Anyway, you are monitoring in a multimeter, but I want to convert them into a voltage also. For example, whatever the value I have got X is a digital value. I want to convert that into equivalent voltage. Whether the voltage whatever I applied is same as what is the voltage I'll read inside the program. So since the voltage is a variable 0 to 5 volts, it is in terms of approximately 10 millivolts resolution. I require a float. I cannot represent an integer because it has got a lot of combinations between 0 to 5 volts. So I'll use a float. So float, let's say y equals, now I'll convert. What is the conversion formula? So 5.0 divided by 1024. So that means that for 1024 for digital output, the equivalent voltage is what? 5 volts. Now, what is you're getting in the X is some digital input between 0 to 1023. So I want to find out what is the corresponding voltage for that. So 0 to 1024. So into X. So what does it mean that? So X corresponds to what voltage? X is what? Digital 0 to 1023. I want to find out 0 to 1023 what I am getting inside my board, that inside the microcontroller, corresponding to what voltage. So what is the formula? So we know that for 1024 you get a 5 volts. Then for X, what is the value? So I will print this value also. So I'll say serial dot print. So voltage equals then again serial dot print. It is y. This is only just printing it properly. Serial dot print ln. Okay. So what I'm printing in the first line, I am printing the the digital value, which is then I am calculating the equivalent voltage. Then I'm printing V equals the value of the Y, and then go to the next line. So I'll just run this program. I will say serial monitor. Now look at that. So I am printing the digital value also, corresponding voltage also I'm printing it. Now I'll change it. See that as if I change it. So you can see that I am printing the digital value also, this also. We can use what is called one small delay so that you can able to observe them properly. Delay of, let's say 200. Okay, so now we'll see that. You can see that 368 corresponding voltage. What is the voltage? So 2.60 is a voltage corresponding to 532. So 655. So 921, 4.50, 1023. So voltage is what? 5 volts if you get 1023. So like that, you can able to calculate what is the actual voltage at this point. What is the beauty of this program is what? Whatever the voltage you are giving through the sensor at this point, in your program, you're able to receive exactly the same thing. This is a beauty. How it has happened? First, it is converted into digital value. Then we use a formula to convert back into what? Analog. So effectively, this program gives me what? Whatever the voltage changes happening at each of these pins, I can measure inside my program. Inside, I can get them inside my program and use it for whatever the logics I require. So it is effectively saying that any changes 0 to 5 volts with a resolution of 10 millivolts, accuracy of 10 millivolts, you can able to catch them inside your program for further analysis. So that is the meaning of this one. Now, so now I'll go to, is it audible and visible? Hello?
Yes, sir.
Yeah, okay. So now what I will do is we will just take now one component, one sensor. I will take it. Yes, sir. Now instead of potentiometer, we will see that how sensors can be used, in the place. So now, so I've just kept this like that as it is. Now I'll take one more sensor, some sensor. So there are a lot of sensors available. If you are able to understand one sensor working, any one sensor working, how does a sensor works and everything, you can able to interface any sensors in your life. There is no differences there. Only thing is you should know how to use a multimeter, you should know how to use a potentiometer, you should know how to catch them values in the program. So now I'll take a simple sensor, let's say photoresistor. I'll take it LDR, we call it a photoresistor. I'll take a photoresistor. I'll bring it here. Now, what is the logic of a photoresistor? What is the logic of a photoresistor? So it is also called as an LDR, a light dependent resistor, or a cadmium sulfide cell. It is basically a photo cell that works on the principle of photoconductivity. The passive component, this is a passive component because you don't require a power supply to make it work. So it's a the passive component is basically a resistor whose resistance value decreases when the intensity of light decreases. In the sense, the more the light you throw on this, the resistance value decreases. So LDRs, light dependent resistors, are used to detect light levels. For example, in automatic security lights or street lights. So the resistance decreases as the light intensity increases. So this is the concept of your LDR. Now going back to the logic here. Now LDR is nothing but a resistor. So nothing but a resistor means what? You should build a small circuit around that so that as the resistance value changes, I should be able to produce a corresponding voltage. Always you have to remember that. See, you may get hundreds of sensors in the market. Each is capable of producing certain change. Maybe you have a sensor which produces change in the current. You may have a sensor which produces some change in the resistance. So you should be able to build a small circuit around the sensors so that you should bring the change in the format what Arduino can measure. What does Arduino can measure? We know that it can identify the change between the 0 to 5 volts. That means that it's your responsibility to build a circuit around the sensors to bring the change or to produce a change between the 0 to 5 volts so that it's suitable for this sensor. If you use another microcontroller that provides ADC inputs 0 to 2.8 volts, then what? You cannot use the same circuit. You should modify the circuit so that you should be able to produce what? Change in that range. By chance, if you build a circuit which produces change which is more than what it can tolerate, let's say 5 volts, your board will go at any cost. That is why you should not connect the sensor directly to the Arduino. Take a multimeter, measure that. Is the output maximum is only 5 volts? Is the input, that is a lower value, is only the minimum is 0 voltage, it's not a negative voltage. You should make sure that all those things before you connect it. Now I taken a LDR. So it is nothing but a variable resistor. So I will connect that to the microcontroller. Now I will build a small voltage divider network. So I will take a resistor. So I'll connect the resistor to here. I will make the resistance value 10 kilo ohms. So it can be little variation also. Based on that, the sensitivity of the circuit may vary. So I have taken 10 kilo ohms. Now I will connect the upper point of this LDR to the VCC. So VCC is already available here. So and other point, lower point to the ground, I'll connect it. So I will just select this. So I'll just connect it to the ground. So I'll take another point. I'll just Okay. I'll connect the, okay, VCC, I'm just connecting it. So now what I've done is, so I have connected one point to the VCC, 5 volts. I have connected other point. To the ground. I have connected other point to the ground. I have connected it now. So where is a point now which is going to be variable voltage as the light falling on the LDR changes? This is the point. This is the point. See that now. So this is nothing but what? Voltage divider network. This is nothing but a voltage divider network. So look at this here for a moment. So I have on my circuit LDR. So I have a resistor of 10K connected here, 10K. The upside I've connected to the 5 volts here. Now this is equivalent to what? A resistor. So now as the light falls on this one, this resistor value changes. So what is the point I'm measuring? This is the point I'm measuring to analog input. I'm giving to this to the analog input. Now as the light changes, what will happen? The voltage at this point will changes. Now if the light, for example, light is more, the more the light falls on the LDR, what will happen? The value of the LDR, that is this resistance, becomes less. Whenever this resistance is less compared to what this resistance, the voltage at this point is more. So that is, it is a more. So voltage is more when the light is what? Light is more. So naturally, when the light is less, what will happen? This value of the resistor becomes lesser. When the value of the resistor becomes more. So in the sense, what will happen comparatively? So the value of the LDR is comparatively is equivalent or comparatively same as this resistor. In such cases, what will happen? So the voltage will comes down. So when the light is also comes down. So we should understand that more the voltage I'm getting, that means that what? Light is falling on the LDR is more. Light is more. So more the voltage. So what does it mean? That light is more. So less the voltage. What does it mean? That light is less. So this principle you have to understand, because we have connected the circuit like that. You can connect the circuit in a varieties of ways. If you connect the resistor upside and connect the ground the other side, then it will be different. See, I have connected the resistor one end to the ground. If you connect the resistor one end to the VCC, the other end to the ground, the behavior would have been different. For this circuit, for this type of biasing circuit, the behavior will be like this. As the light increases, my voltage increases. That you have to understand. So same principle you cannot apply to all circuits. Now I'll come back to here. So now I know the principle way it works. So I said this is the point. This is the point I have to connect to analog input. So I will go to the A2 point is there, analog A1. So I will connect A1 to this point. So A1 to this point. Now, so A1 is connected to circuit called LDR circuit, so which recognizes the light intensity. A0 is connected to potentiometer. Now, so now I will write the code for that. Now what I'll do, I will not change any of the code here. Instead of A0, I will just say A1 now. So I'm not going to read anything about the potentiometer now. I'm going to read about only the light intensity. Now, what is I am going to see at the output? As the light changes, my values, that is voltage, also should changes. The digital value also should be able to change. Let's see that whether it works or not. So now my program is completed. Now I have built a circuit. I'm monitoring at the A1 point. A1 is a point where I'm reading the voltage corresponding to the light intensity. Now we will see that. We will run this code. We will run this code. So I will just pull this here, somewhere here. So I pull the circuit somewhere here so that I can able to see that output. Okay. Now I'll press the serial monitor. Now see that voltage, you're getting something. Now I will change the light intensity.
So it is not connected.
It's not connected. Huh?
So you remove the resistor.
Okay, I remove the resistor. Okay. So now, I have not connected the resistor there. Okay. Okay, so let's say here and run the code. Okay, so I will drag that, but dragging that. Okay.
So by clicking on the blank space, like white paper canvas, you can just drag the entire thing.
Okay. Okay. Now, yeah. So now I'll start the simulation and say code. Okay. So now serial monitor, I'm getting the values here. Now I click on that device. I'll change the values. You can look at the, anyway, multimeter is connected to the other point. So we can change the multimeter connection also. And instead of this to this point also, that also can change later. So now see that as I vary the intensity of the LDR, so the values are changing. See that the different values are changing. Let's say, for example, if I keep it here, approximately how much I'm getting, around 945. That means that, so the light intensity around this area, that means from this to this one, it varying from 900 to this one. So now with this, for this biasing circuit, you'll get an idea. Oh, this is the range I'm looking for. What light you want to look for it, you measure, make a measurement first. You do the calculation like this. For example, let's say for 900 and above, I want to take as a light is a decision. I want to take it, whether my light should be off or on. So what I'll do is, so now I'll just build a small circuit to demonstrate whether can I build a smart street light out of that. So what I'll do is I'll just get one LED. I'll just get LED. I'll just connect to some points. Let's say I will connect here. So let's say one ground point I'll connect to. I've connected here, and then the, let's say 7, I have connected to anode. I just connected it. So I've connected the one LED. So this also, what I'll do is I'll, instead of I will remove this and put to the LDR. So that is to the A1, I'll put it. I'll put the A1. So now I changed. So what I connected one LED to the pin number 7, and I have connected the multimeter to the A1 point instead of A0. Now I'll go to the code. So I'll just add one LED. So pin mode is already there. So instead of 13, I'll use the pin mode for LED 7 as an output device. I'll put some logic here. So what is my logic required here? Say for example, if, so what is the range digital value? X is a digital value. I know that if X is greater than, let's say 900, that means that the street light should be off. In a sense, digital right, pin number 7. So pin number 7, low. Let's say else digital right. So 7. So let's say high. So what I've done, so I've just small logic I've introduced. So how did I decide on 900? Because I conducted an experiment on the, actually in the field. I've observed using a multimeter and also serial monitor. Oh, I found that if around 900 for this light intensity, I should be able to switch off. Like this is a decision you have to take based on your biasing circuit. That depends upon what value of the resistor you use, and actual experimentation you have to do out in the field. So now again, I run this program. So now I have some value there, correct? Now that is, I will change the value of this one. So Okay. Okay, now I will run this. I will change the intensity. See, as I bring it down, the light is more, correct now, light is off. See that? It is changing now. You can put a resistor with the LED also. See that it is changing. So this is the concept of linking a sensor to the output device. See, I have linked now a sensor called an LDR to an output device called light. You can link it to anything. Actually, if you use by using a relays, either solid state or mechanical relays, you can really connect actual LED. That is actual 220 volts operating your LEDs or the tube lights or whatever, maybe fan, anything you can connect it. Only one component required is you would use one component called relays. So that we will see that unit 4 we'll learn about that. So see that. So this is the beauty of this circuit. So now this completes an understanding about how we can use analog inputs of an Arduino board to implement interfacing of sensors to the circuits. How we have used in these explanations how to use a potentiometer, how to use a multimeter, how to use an LDR, yes or no, and how to write a program to interact with them. So if you have any doubts, you can raise certain doubts. So I thought of completing analog output also, but anyway, we'll see. We'll give some break. Yeah, if any doubts is there, somebody was asking, you can ask the doubts. I'll stop the recording here for some time. Okay.